Hello, and thank you for attending this webinar. We will be recording the webinar in case people are not able to view it live and they can look at it later. This is the webinar on peak performance neurofeedback applications. I'm Harry Campbell from Biofeedback Resources International, and I'm joined by Dr. Jorge Palacios, and he'll tell you a little bit more about himself when he starts his section. I'm going to start off with introduction to the topic, and then I will hand it off to Dr. Palacios, and he'll continue with the material. This is an introduction. It's not a full training in peak performance neurofeedback applications, but just to introduce the topic and tell some things about it. We have planned a neurofeedback training that we're going to be doing in St. Petersburg, Florida. It's scheduled for February 21st through the 24th, and more information will be available about that. In that training, it's going to be a full training that we will teach all about neurofeedback, and we will also be teaching about QEEG, brain mapping, and the topics, including peak performance, but the other topics that we talked about earlier, like things like attention and brain injury and so on. So those are some of the other applications of neurofeedback that we'll be covering in the training. And so I'm going to go ahead and share my screen here. And we'll get started. Okay. All right, so this is the topic. And so this is one of the things that I was taught a long time ago. And I know Dr. Palacios remembers Adam Crane, who was my first teacher in biofeedback and neurofeedback, and I worked with him for a long time. And I remember during the trainings when he was training new neurofeedback or biofeedback providers, one of the things that he would suggest is that, of course, most people that are doing neurofeedback would be doing mostly clinical work. And they would be working with people that had all kinds of problems, including anxiety and depression and ADHD and brain injuries and insomnia and so on. And even in therapy, because many of the people that come into neurofeedback are various types of therapists, psychologists, social workers, mental health counselors, and they spend a lot of time listening to problems and dealing with problems and hearing about problems and trying to help people with those problems. And it can also be stressful for the provider. And so he used to recommend that you try to work in to your practice some performance work. So it's not all clinical work, that you do some performance work where you're actually working with people to improve something in that they have to perform at, whether, and we'll talk about some of the different things that would be, but one example would be sports. And so if someone is an athlete, helping them to improve at their sport is different than working with someone who is depressed. Both are useful. One may be more important in many ways than the other, but it's a way to balance the practice that you're doing, and that always stuck with me, and I think it's a good advice. So these are some of the types of performance applications that we get into, and so you think of sports. Many times when people think of peak performance, they're first thinking about sports, and maybe only thinking about sports. Of course, it's a big one, and they're in sports. It's strange because there's so much money involved in sports for something that is really not important, but people pay a lot of money for sports. You can see the salary of the athletes and the ticket prices and the money that's made in the TV revenue deals and all those kinds of things. And so there's a lot of money in sports, and it's sometimes not very logical. You could have someone who does brain surgery saving someone's life, not making as much money as an athlete who does something that is relatively unimportant, but it doesn't matter. The bottom line is that people pay, and there's a big market, and athletes are always looking for an edge. I think the athletes themselves, the owners, the coaches, and so on, if there's something that can help the athletes to improve their capabilities, their performance, it's something that they would be interested in. Then you have education, so you can think about academic performance. There's business applications, so you think of anyone who is in business, that whether it's in sales or other types of tasks that people do in business, if they're performing at 100%, that means more for the bottom line. If they are performing at less than 100%, then there's money being lost. So there is often some interest in doing things that can improve performance there. And you can think of other types of performance, people who play musical instruments, people who sing, people who act, and so on. These are all areas that you have people that would be looking for, how can I perform better? All of these types of performance are mind-body activities. You can't perform without using your mind, your body, usually both of them together. And so things that can improve mind-body performance should also lead to improvements in performance. So learning to improve the mind-body regulation, the way that the mind and body work together as a system, can lead to improved performance. And we think about the connection between the brain and the muscles and all the other parts of the body. And those are some of the things that are addressed when we do neurofeedback. This is just a series of some pictures that I'm going to show you here and talk a little bit about. So this is one that was a Canadian astronaut, and they were measuring brain activity and also other things, their respiration, and maybe looking at things like heart rate variability, and so on. And they want to see what's going on with the physiology, what's going on with the brain activity as the person is doing different types of tasks. In this case, they were doing a underwater mission and looking at what was going on with the physiology. This is an image of a air rifle shooter that competed in the Olympics and won a gold medal. And part of his training preparing for the competition was 150 hours of neurofeedback and biofeedback. So besides all the other things that he would do in his training, they devoted 150 hours to training the mind body using the technology that we're talking about. And then you have the AC Milan soccer team, or you might say football, depending on what you're used to. They set up what was famously called the mind room, where they had their athletes train using neurofeedback and biofeedback as a way to improve the functioning, the regulation of their brain and body system, so that they can reduce stress and also have better control over their body and the things that they have to do to perform their sport. And this is just some an article that was written about that. And so it's not just the physical training and the learning the plays and so on, and physical conditioning, but also training the mind. And then you have here, Sue Wilson is one of the people that I've known for some time that does training with athletes using neurofeedback to help athletes, like for instance, tennis players and so on, to improve their ability to use their brain to play their sport properly. And some of the things that we'll look at, I'm sure Dr. Palacios will get into a little bit more, is when we have the different brain waves, some that are more associated with activity, focus, and others that are more associated with relaxation and so on, being able to shift the activity in these different frequency ranges is part of what would be looked at. And also reducing things like anxiety, even if sometimes anxiety, or you might just say nervousness, is not at a level that would be treated clinically, it can be enough to affect performance, and working with that can help the performance. Here's another article that was talking about training the brain, and then this is also having to do with performance. And if anyone wants more information on any specific articles that we mentioned, I'd be happy to share any of those with you. So this is continuing with that article, and it's going into talking more about looking at the activity in the brain and what activity we would be looking to affect or change based on the neurofeedback. So that's just a little introduction to what we're talking about in this topic. And I'm going to hand things over to Dr. Palacios, and he will continue to give us some more details about this. And of course, we'll give you information at the end of the webinar today about how you can get more information about the training that we're going to be doing in February in St. Petersburg. But you can also take this information down, the phone number, toll free, and the other number to call my office, and also the website where you can get information on the trainings and register for additional training. So I'm going to stop sharing my screen, and I will hand it over. So Dr. Palacios, please continue.
Thank you very much, Harry. Well, let's begin with this part of the webinar. As Harry was telling us, this is for just a brief introduction, but one of the topics we are going to talk about in our seminar next February 21st to 24th in the next year in St. Petersburg, Florida. We have just changed location to a new site and to start with a new trend of our already well-known biofeedback and neurofeedback seminars. Today, let's continue talking about peak performance, and I am going to address two basic elements. One of them is about QEEG biofeedback and the role into the protocols of peak performance training in different applications, and also the new tendency, which is the HD. HD stands for high density QEEG, which is also is going to be related to biofeedback in the near future. We have to be prepared because we are about to celebrate the first 100 years of EEG on the next year. That is covering the applications and the achievements. This is going to be one of our most important years for all the people that is working in EEG and with QEEG and QEEG. We have gone a long way since the first work of Caden and pioneers work of Hans Berger in the human EEG. I am going to discuss some elements that I have already talked about in our previous webinars that are related to the same basic element, which is the main ingredient when you are working with EEG and neurofeedback. All in neurofeedback is about EEG. One channel, 32 channels, 19 channels, 128 or even more channels are related to EEG. This element is precisely what we call neurophysiological markers. Neurophysiological markers are pretty well known as a specific brainwaves organization that have characteristics elements related to specific responses to external or internal events, cognition, physiological states, and physiological conditions also. There have been described a lot of neurophysiological markers. I am going to mention just a few. Some have been discovered in specific laboratories, other ones in the clinical settings. And for that, we can mention, just to mention a few, the T300, which is related, it's an event-related potential to attentional states, and the two are ERPs, which are related to visual processings, and 107 and 400 related to visual processing and semantic comprehension. When we talk about these elements, 300, 100, and 170, 400, we are measuring in milliseconds the latency of these events. And we also have to talk about, for example, the alpha waves, which were the first one that were described in the very first works of Hans Berger. And also we have to talk about the frontal midline theta activity, which is related to memory processes. But in this case, this webinar, we have to discuss about the achievements related to the use of QEEG biofeedback procedures and for the increment and predomination of alpha waves. This is the central part of the beginning of the use of the neurofeedback training related to peak performance. Today we have a lot of protocols. It has become since the 1990s and previous applications, but it has become a very strong field of application that it is not pretty well known for many people. In this case, and just only in this case, I am going to talk about alpha waves and the way it is organized with the characteristic anterior-posterior gradient, which is a specific distribution during awake states with eyes closed and with eyes open. It is also named, it was also named as the default mode state or resting state of the brain. And it is called resting state of the brain because it is a condition when we do not expect to obtain any ERP because we are not presenting any kind of stimulation to that brain in that particular moment. So that is why it received the name of resting state of the brain, or also the default mode that was coined in the beginning of this century, in the year 2000, due to some work related to fMRI. QEEG has become a useful tool to restore natural organization for the resting state of the brain. Let me tell you that one basic element is that when we are talking about neurofeedback, we are talking about QEEG because we are using computers. It doesn't matter. We are working with one channel, with 19 channels, with 32 or 128 channels, we are always talking about quantitative EEG, because the machine has to do a specific kind of processing, of mathematical processing of the EEG signal. In this image, we can see the distribution, the classical distribution from the posterior areas to the frontal areas of the alpha traces. This is a pretty specific example how the amplitude of the alpha traces become less clear and has alpha traces have less amplitude when it comes to the frontal areas of the brain. Here we have the frontal areas, FP1, FP2, F7, F3, F6 electrodes, and here we have central electrodes, and this part corresponds to the parieto-temporal and occipital electrodes. There's another example when we can observe this type of organization of the alpha traces. We are recording here the typical resting state of the brain. In a very classical analysis of the power spectrum display of the whole frequency, we can observe the difference between eyes closed and eyes open. We can observe some kind of alpha traces with eyes open, but the difference is the amount of the amplitude, which is very, very different between the two states. But in these cases, both PSDs, we are power spectrum displays of the frequencies. We are observing how the alpha traces have more amplitude during the recordings with the eyes closed. And sometimes when we have the eyes closed or eyes open, we can observe the same type of traces. That means no alpha traces clearly defined with a very low amplitude. This is an example with the recordings in the frontal electrodes in the resting states with the eyes open. Here we observe a typical power spectrum display. This was made on the EEG lab neuroinformatics environment, and we can observe here in this recording, particularly of the resting state, the specific distribution of the alpha traces in the occipital area. And in this one, made with a recording obtained just a few days ago, last week, of recording of the resting state with the eyes closed. This is a more complex analysis of the PSD. We can observe the different frequencies, observe very clearly how it is getting more organized since the 7 Hertz to the 10 Hertz, the alpha traces with the high amplitude or the high concentration of the voltage, and we can observe this kind of distribution of the amplitude of the alpha traces. Nevertheless, in this case in particular, we have to observe certain kind of activity. It was made during the eyes closed, with the eyes closed, that certain kind of fast activity corresponding to the beta traces, beta activity between the 15 and 16, maybe to the 22 Hertz, are with more amplitude than expected. This is a specific case of anxiety, of a regular and natural anxiety, stress condition obtained analyzing the resting state of the brain. In this case, we have also to consider that since we are obtaining the recordings of a person that is in a different emotional state, which is predominating, we can see a very different way of the distributions of the brain activity. Before we continue, we have to talk a little bit about neurophysiological plasticity. Since many years ago, it has been found that under certain learning conditions, QEEG activity can be modified according to specific parameters, mainly amplitude. Frequency cannot be modified. Frequency bands will maintain the same characteristics all the time. But here in neurofeedback, we are working with the modification of the amplitude of the brainwaves. The more specific characteristic of the brain plasticity related to brainwaves is based in the changes of amplitude, as we just observed in the case of these recordings that I presented before, where the distribution of the resting state was not what it was expected, because the person was experimenting a mild anxiety state. When we are using systematically the neurofeedback applications, we are going to find that what is getting modified and which is getting as a result to certain brain waves predominate over other ones is precisely the effect of learning in the organization and reorganization of the amplitude in the PSV, in the power spectrum display. In the case of the health application, this element is the most important. And this is the element that has been the key for the development of a different type of specific procedures that has been used for induced high performance sports, high responsibility professions and careers, conditions that have made better not only performance for those people that are being trained with all these procedures, but also more happy and have made their professions and their activities more enjoyable. They enjoy more their activities after the neurofeedback training, which is a basic element of effects of this kind of training. Now, what is this made for? Well, this is made of this. How can we modify this type of activity with the eyes closed? This is a central electrode with a very low amount of alpha tracing, and this is eyes closed, which is the most typical and most known way of analysis of the study of the alpha traces, and convert that into this with some traces in the central electrodes. Here we have parietal, temporal, and occipital, and we have central here. But if we take a look at the previous, this one, we can observe the central electrodes without alpha tracing, and after the training, we have a very different organization, much more similar to the one organization I showed before, where we can observe the anterior-posterior grading that is characteristic of the alpha distribution during the resting state. Well, we can achieve that due to certain procedures. Let's talk about an example of the general peak performance procedure. It's pretty common that in many cases we can have certain type of assessments like this one that you are looking in the screen. This is an assessment obtained with a bioinformatic environment based in the measuring of the RR or peak-to-peak measures in the ECG. And we can observe here how, nevertheless, the parasympathetic tone is stable and with signs of healthy condition. We can observe the sympathetic tone very activated. In fact, it exceeds the second standard deviation, which is far away from the t-distorting measures and also the C scores. So it is pretty common that in many applications during peak performance, we can obtain this type of readings after a simple stress profile. This was obtained with a typical stress profile just yesterday. This was made yesterday at 11 o'clock Mexico City time. And we can observe here in different conditions the baseline in the measures R2R and HR. That means peak to peak, the R component of the ECG, and during the baseline, we can observe here the baseline. We can observe here the cognitive stressor, which is very well known up to date during this type of studies. The people is asked, the person that is doing the study is asked to count downwards from 3,000 to an own, resting resting number 7, and to count in loud voice and try to not do any kind of mistakes. And this person did it pretty well, but the price was high. She began to have a lot of high frequency in the heart rate. And then we have the rest, the first rest period, then a past stressor, then another rest period. You can see the clear difference between one another. And then we have a recent stressor. It's pretty clear the different condition: baseline, cognitive stressor, rest. Oops, sorry for that. Rest, and then past stressor, rest, and then recent stressor. Here it is, and finally rest at the end of the study. This is the whole analysis with all the periods of the stress profile. Here we have the different type of measures during the RR condition, and also we have the time frequency distribution, and we can observe how the low frequency values are not pretty what it were expected, which is a dominance of these elements during the rest condition. In fact, during the rest condition, the high concentration of the low frequency, which is the balance between the three elements of the heart rate, is just not present. After peripheral biofeedback, which is HRV biofeedback, in this case, we can obtain this type of recording. Take a look at the way this person working with desensitization achieves a high concentration of power. We also are talking here of PSD, and a proper balance of the PNS and S with the higher predominance of the low frequency. Well, this type of training is a prerequisite for the training in peak performance before you start working with QEEG or with neurofeedback, with QEEG biofeedback or with neurofeedback. Is to consider some basic concepts about default mode network. And why? Because why about default mode network? Because all the procedures made for peak performance are elements. One, to reestablish the organization of the default mode network. It doesn't matter it is with eyes closed or with eyes open, and also with other neurophysiological markers. The complete elements of neurophysiological markers that are restored with this type of training are going to be discussed during our seminar next February. But for the moment, we can talk a little bit about the default network. What is this? What is default network? Well, default network is the high concentration of the brain activity in specific zones of the brain during the condition that I was mentioned before. This condition is the condition in which the brain is not receiving any kind of stimulation. It is not working. It is also known that the default network, as I already told you, as the default state network. It is a large network. It is organized in great areas of the brain, and it can be identified in all these between all these areas of the brain: the dorsal medial prefrontal cortex, the posterior cingulate cortex, precisely the precuneus, which is this high concentration of activity, the higher concentration of activity. Here is the reference of this this work, which is beautiful. This is fMRI, and also the angular gyres here. These are the areas of the default mode network. Any brain in the healthy state will show this type of organization. Well, this is obtained with fMRI. But what happens with the EEG? And what this has to do with neurofeedback? Well, it has to do anything. Everything, and also it has to do not only everything, but it is the main element of work. First of all, we have to use certain tools. One of them is to identify the stroke, and using the stroke atlas, the same areas of the brain. As you can see, the recent studies, the more recent studies, like this atlas, for example, of the stroke, is showing us the specific areas of the brain that are related to many other functions, but in this case, a specific case, to the default mode network. In the precuneus, in the angular gyres, and of course in dorsal medial prefrontal cortex. It has its story after many years with the advancement of the PET, of the positron emission tomography. many researchers began to scan the brain with a different point of view. And when it came to the functional MRI, they found, you have the reference in the screen, the specific organization of the brain activity during this specific condition. Let me tell you that this methodology, since the 1990s and after the 2001, which this author coined the term default mode in 2001, it has become a great amount of prolific work, but not only with DMN, but also with the many others brain networks. Again, here we're looking at the DMN, but we have to consider more precise atlas, like this one from Schaffer, that has a more specific parcellation of the default mode. As I told you, there are parcellations for many other type of cerebral networks. Any kind of networks up to date. It has been a huge and prolific field of work. And we can join together the areas of Schaffer and the TRK fibers. This comes from the tractography studies of the conductivity of the fibers in the brain. And if we do these elements, we join these elements together, we can see different views of the brain. Here we have the top and the bottom of the brain, left and right, and we have front and occipital cortex with the areas of the default mode network. I identified only one hemisphere just not to fill the images with too much information. And we can join all this into neuroinformatic environments and to obtain very precise measures of the brain activity and its distribution in any kind of condition. And we are talking about EEG. We are not talking only about MRI or fMRI. We are talking only here about two key elements, neuroinformatics and EEG. So it takes two elements. One, to obtain the acquisition of signals in a specific condition. That could be resting state of the brain. And also, it could be not only resting state of the brain, but also could be another condition. For example, looking at the performance of the team in a specific competition, looking at the self-performance during a discussion, during a specific operation, during a specific condition of work, during a specific performance in the theater or in the movies. So after obtaining that information, we can look at the distribution of the sources of the brain activity, and we can observe how the brain, the different traces of the different frequencies of the brain are distributed. Here we have delta traces, theta traces. This is the midline, frontal midline theta. Here we have alpha. Here we have some beta, some gamma also, and gamma 1 and gamma 2. This shows, after many years of study, and how different is the way the brain activity can be observed with more precise tools. And this is a very clear view why during the resting condition of the brain, it is not inactive. Today, everybody agrees in this field that the brain is pretty active. Different type of activity as if it is solving a mathematical problem, for example, but it is active. Daydreaming, wandering, with some illusions, thinking with spontaneous thinking, and the way the gamma activity and some beta activity is organization is a good example of that. By the way, this has been done using another neuroinformatic environment, which is called Brainstorm from McGill University, following the pipeline of Tadel and Valiet et al. And also we did the analysis of the brainwaves following the NISO et al. Pipeline for this purpose. Here we're looking at this is the basic element, the default mode network, the strong connectivity of the default network fibers distributed precisely in the zones that we mentioned before. Here, during the resting states, with the eyes closed in this case, after the neurofeedback training. But this is one case. If we analyze, this is the work of NISO et al. This is a very different type but useful work. Here we can observe the study of 400 subjects that were studied with MEG recordings using 412 channels, and we can observe here the distribution of delta, theta, with the midline, frontal midline theta, alpha, beta. As you can see, it is not unusual to obtain beta activity with the eyes closed. Once, many years ago, it was considered even pathological, even dysfunctional, but it is not. It is not. It is just only a specific type of beta activity with a very narrow band. Here we have gamma and gamma 1 and gamma 2 bands distributed. This is a control group. And this is one subject. Again, the comparison. One subject, the group. One subject, the group. One subject, the group again, with a lateral view of the left hemisphere, and again, one subject. So, as you can see, one of the most important contributions has been made by joining and creating one of the first mixed protocols in the biofeedback and neurofeedback history, which is the performance protocol that is based on the previous training in the HRB biofeedback with the low frequency predominance, and then the QEEG or just classical neurofeedback training for the predominance of the alpha activity during the resting state condition. And why is that? Well, the simple reason is because when a people is over stress, under too much pressure due to responsibility, just a few moments ago, Harry was mentioned to us that sports is is a kind of job where athletes make a lot of money, much more money than neurophysiologists, for example. And believe us, neurophysiologists do very hard work. But both neurophysiologists, clinical or researchers, and I don't know, soccer players, American football players, tennis players, have a lot of responsibility. And this responsibility has effects on the pressure, on the tension, and this comes to stress. So we all need to be trained with this type of products. And we are going to talk more about all these type of procedures during our seminar. Let's talk about a little of the future, not too much of the future, just a little. Let's talk about QEEG biofeedback, but with the HD characteristic, high density. And why high density? Well, because we're using here 128 channels. In color, you see the parcellation of Schaffers, the whole networks. Dorsal attention network, ventral attention network, default mode network, visual network, etc. So here we are looking at the whole electrodes projected to the MRI, the MRI of the participant. Then we can observe here how the activity is getting organized with the eyes closed. We see very different organization here. Compared with EMG, MEG, excuse me, and also with EEG of high but low density, like for example, the images of 32 channels that I just present you. And this is because of the high resolution that working with more a number of channels, of EEG channels, can be obtained. Harry just showed us this NEMO project that was a very interesting project. And well, of course, the work with the Infinity device for HRV training was very important, but also you see the participant with a lot of small dots in the head that were all around his head. Well, this is a specific EEG system, QEEG system, that is called geodesical system, and it covers the whole head because it has the capability of obtaining signals that become of the bottom of the brain. Well, imagine this type of images with this precision can be obtained with, by the way, we have here the different areas of Schaffer of the default mode with much more defined precision of the distribution of the brain activity. And imagine this is only with 128. That system, the geodesical system, has 315 channels. Imagine the definition that we can obtain that. That's the reason why I said at the beginning, we have came a long way with EEG since those days, 100 years ago, when Caton and later Hansberger began the work with EEG. And what if we project the EEG into the MRI of the subject? This is not fMRI, not MRI. This is a simple MRI that has the projection of the electrical activity. And take a look how precise the organization of the default mode can be obtained. In the precuneus and in the frontal areas and the angular gyres. This is the concentration, the degree of concentration with a sagittal, coronal, and axial view. This is that. But we can obtain more precision. Here it is. Take a look at the different areas and take a look at this beautiful projection into the precuneus, which is, it is more precise than fMRI. And we can see another example of the, and we have to consider here that with EEG, we have temporal and spatial resolution, both. The temporal resolution of the EEG is one of the best, most important characteristics. But due to the work with neuroinformatics, we can obtain a specific spatial resolution, like, for example, in this case. This is a beautiful example of the default mode network. And now you can imagine of the future. Let's take a look at this other image. Is the same case, just left hemisphere and right hemisphere from the sagittal view. Take a look at the different distribution in the precuneus. And I want to finish with these images. This is another images, which is more lateral in the left hemisphere. We have a different slices of the default mode network. Now you just have to imagine what can be achieved if we perform neurofeedback, taking not only 400, but 2,000 or 5,000 people database as reference, and using HD QEEG as a tool for the neurofeedback of the brain activity, apply, of course, to the clinical typical uses, but also to peak performance, which is related precisely to the default mode network as the basic state of the brain related to health. And I would like to finish with this. This is the neuroinformatic environment. These images came from this database. This database has all the information of the Atlas from Schaffer, and has the recordings, and we process the information, and we projected the results to the fMRI of the subject, obtaining this precise localization of the brainwaves. So this is the future. And we can, now I am going to stop sharing the screen. And as you can see, we can expect for the not so far, but more near future, a specific type of work with neurofeedback, two different kinds of application, but in this case, for peak performance, because peak performance is based on the neurofeedback of the default mode network mainly. So we expect you all in our next seminar to talk more about this.
So thank you. As usual, I always learn something when we do these together, listening to you. So I'm looking forward to learning more about, especially those futuristic things that are coming, besides the the things that we've been doing in the past with the neurofeedback training, and also the other imaging that we have been doing, but now with the new technology, new software, there's even more we can do. And I think in the area of performance, I think it will be exciting to people who haven't looked at it before.
Yeah.
People, like when we started with some of the clinical applications in neurofeedback, many of us were doing some neurofeedback before it got very popular. But I think when the applications of ADHD and substance abuse came along, then
Mhm.
many people started to become more interested in neurofeedback. And I
Yeah.
think the same thing could happen with performance in another way. So
Mhm.
I think there's some exciting things to happen. And if people are wanted to learn more, they can attend the training that we're going to do, so that rather than just having about 45 minutes to learn about it, we have 4 days to learn about it.
They will have more time to learn many things.
All right, so I'm going to stop the recording, and we'll talk for a couple of minutes after that, and then hopefully we'll get people to join us in the training. Again, the information for the training can be found on the website biofeedbackinternational.com. You can also call the toll-free number if you're in the US, 877-669-6463, or 914-762-4646. Hope to see you all, or at least some of you that view this soon.